Welcome back, boys and girls. This is week 4 of our 8th grade math pre-algebra instructional packet. This is this week's overview. I'm simply just overviewing what we're working on this week, doing a small little reteach, and hoping that it can get you started, jog your memory, to be able to work on this assignments for this week. If you do require more assistance, I advise you to please make sure to view your math teachers' instructional videos as well, because those are going to be a little bit more in detail and in depth and go day by day. Okay, and of course, past this video and your regular math teachers' videos, if you still require further assistance or you're still not sure about something, or you have a question, we can be reached via Google Classroom, email, text, or phone. This week, we are going over proportional relationships, and that is 8.4b. So remember, there are 4 different ways that you can be able to find proportional relationships. Now, remember that we have our verbal description, we have an equation, we have our table of values, and we have a graph. So these are the 4 different representations that we can see or identify a proportional relationship. So let's overview this. Remember that your proportional relationships, okay, your equation is y equals kx. Okay, in the previous week, we were working with y equals mx plus b. But because we're working specifically with proportional relationships, then it's going to be y equals kx, because there is no y-intercept. Okay, the y-intercept is going to be understood to be 0. And how do we know that? Well, notice down here that, remember about proportional relationships, it's always the line will pass through the 0, 0, which is also known as my origin. So because I do not have a y-intercept and I automatically pass to 0, 0, that's what makes it proportional. Now, if we're looking for the slope or the constant of proportionality, we're going to use this formula right here, k equals y over x. So we simply do y over x, and that will give me my constant of proportionality. Constant of proportionality is also another word for slope. So notice that in my equation for proportional relationship, the k is my constant of proportionality. So whatever my constant that is attached to my variable is my constant proportionality or my slope. Okay, so in this case, if I had y equals 3x, the 3 is my constant proportionality, or 3 is my slope. Let me clear this. Okay, let's move down a little bit. So here's an example. So Juan made a 200-mile road trip in 4 hours. What was his unit rate in miles per hour? So what are they asking us? They want to know unit rate. That right there is going to be my clue word when it comes to my word problem. Unit rate is another word for per one. Per one. Okay. It could also be my constant of proportionality, or it could be also my slope. So when you see the word unit rate, that's a clue that they want us to find the per one, the constant of proportionality, or the slope. Either way that you want to look at it, They all mean the same thing. So they want to know the unit rate of miles per hour. So if we go back to the word problem, it says that Juan made a 200-mile road trip in 4 hours. So they want miles per hour. Remember that per means to divide. Okay. So you would set it up just like this: 200 miles over 4. This right here is my K equals Y over X. This is what I set up here, my constant of proportionality, because that's what I'm looking for. So I did my Y over my X. My Y is the miles that he of the road trip and the hours that it took him. So when we do 200 divided by 4, what do we get? Put in your calculators. Right. We're going to get 50 miles per hour. Okay. And this right here is my K, or my constant of proportionality. Now, if I wanted to write this in an equation, if I wanted to write it in my proportional relationship or proportional equation, I would write it as Y equals 50x. So that's how it would be. There's my equation. Okay. Here's my K equals Y over X setup. Okay. So this is working on a proportional relationship from a word problem. Okay. We have another one here below. So this one says Mike drove a 330-mile road trip in 6 hours. What is Mike's unit rate? So there's that word again, unit rate. Okay. So I need to figure out my K. So I'm gonna do my Y over my X. So now, once I write out my formula, I need to input my information. Well, which one is my Y? Well, remember that they want miles per hour. Remember pers to divide, even though it's already set up as my equation here. So in order to find my K, I'm going to do 330 over 6 hours. Now, go ahead and put that into your calculators. And what do you get? Yes, 55. And this is miles per hour. So if I want to write this in my proportional relationship equation, I would write Y equals 55x. Okay, so now all of them will not be as simple as this, but you will find those keywords. Those keywords are going to be there. That unit rate, okay, that's going to be there. So you're going to be able to, as long as you can remember that vocabulary word, those vocabulary words, you'll be able to identify and pick up on those, and you'll know. So don't be discouraged when you get to the word problems. Okay, I know some of us struggle on these, and we tend to shut down, but we got to be able to just read it twice at least, and then look for those clue words that are gonna guide us on what we have to do. Okay, let's move on. So now we have our tables. So remember that just as in the previous weeks, with your tables, yes, you can use stat edit on your TI-84s. So you can input this and do your stat edit and linear regression if you have access to it. Okay, it's great practice. However, for those of you who don't, and even if you do, we should know how to do this by hand. So it's no different than what we did with the word problem. We're gonna use the k equals y over x. We need to find a constant of proportionality. Now we know that these are proportional. Okay, so this only works for proportional relationships, and it's only if we know that it's proportional. If we have a table and we're not, and it could possibly be proportional or non-proportional, we don't want to use this method because it will not work for non-proportional. Only if it's going to be proportional, we can use k equals y over x. So you can choose any ordered pair. In this case, they chose 3 over 12. Now, remember it's y over x, so be careful with that. You need to make sure that's another way that we make our mistakes. We tend to flip them. So make sure that you double check y over x. Okay, my y is 12, so that's on top. My x is 3, so that's on the bottom. And 12 divided by 3 is 4. Okay? Because I guarantee you, if you do it backwards, that answer choice will be there. They know the mistakes that we make, so we want to make sure that we avoid that. So let's look at this one on B. Let's just say we choose 3 over 2, okay, or 3, 2. So remember that um, in an ordered pair, this would be 3 because the x goes first, 2, right? Um, I know sometimes when these are horizontal, sometimes it throws us off. But again, just double check with your formula. Okay, it doesn't take that much. So it doesn't uh, take much to double check that and make sure that we're inputting it correctly. So I want y over x. Well, my y is 2. My x is 3. So it's 2 over 3. And this is already simple. It's already in its simplest form. So my constant of proportionality is 2/3. That's it. If we're working from a table and we know it's proportional, this is all we're doing. Just make sure that whichever ordered pair you choose, that you're inputting it correctly. The y over the x. And that's it. Good. Now, if we go into from a graph, okay, if we're looking at it from a graph, remember that we don't need to find y-intercept, okay, because it is already proportional. So we know that it's going to go through the origin, the 0, 0, and we already see that here in those two, right? So the only thing we need to do is find our y over x. So we can do rise over run if we want. We can pick 2 points like these. Do rise over run. We can do that. Now, but careful because we are working with graphs and we need to make sure that we pay attention to the scale. And notice the scale is not going by ones. From here to here, it went up 20. So even though this is 1, it looks like it's 1, it's not. This is actually 20. And the run, it goes from 2 to 4. So this is actually 2. So when I do my rise over my run, I'm going to write it as 20 over 2. So be careful with that. Make sure we pay attention to those scales. So 20 over 2 reduces to 10. So my constant of proportionality for this one is 10. Now, they went ahead and picked a point, which is another thing you can do, to pick 1 point. So they picked 2 and 20. So they picked this one here. They wrote, well, what's the y? Well, the y is 20. So they put 20 over 2. And then they simplified it. It's the same thing of what you're doing over here. It's just whatever you feel more comfortable with. If you'd rather do the rise over the run because you're familiar with it and you feel that you're less likely to make a mistake, fine. Just make sure you pay attention to the scales. If you're gonna just choose a point, you can do that too. We'll do that over here. So let's say here I choose this point right here. So this ordered pair is gonna be 530. So this is 5, comma 30. So now remember my formula is gonna be K equals Y over X. So again, just make sure that we pay attention to what we're putting. My Y is 30. If you're not sure, you can look on your Y axis over here. It's 30. So it's 30 over my X, which is 5, or I can double check on the graph, 5. So I have 30 over 5. Put that in your calculator, or if you already know what it is, yep, it is 6. So my constant proportionality is 6. So over here I did rise over run. Over here I did my K equals Y over X. Whichever you think is simpler, okay? Do not try to do it a specific way. Do it the way that you feel more comfortable. But there is more than one way to do it. Okay, awesome. Let's scroll down here. Now, here we have equations. Now, on the equations, however, look at what it's asking us up here. They're asking us to identify. They want us to identify if it's proportional or non-proportional. So this is where we got to be careful. Now, how can we tell from an equation if it's proportional or non-proportional? We need to know our equations. We need to know our formulas. What is a formula for proportional? We just went over that. Y equals KX, right? So if all we see is a constant of proportionality with an X, that is telling me that it is proportional. Now, how can I tell if it's non-proportional? Well, remember non-proportional equation is Y equals MX plus B. The big difference is that B, it's going to have plus or minus something. If I have anything in addition to my constant or slope with my variable, then that means I have a y-intercept. If I have a y-intercept, I have a b. If I have a b, I have a non-proportional relationship. That's how I identify it from an equation. So let's just do a couple real quick so that we can go over it. Oh, we'll do these. That's fine. So number one, y equals 3x. Look at your two formulas. Which one is it? P, proportional, or NP, non-proportional? Right, proportional. What about y equals 2x plus 1? Look at your two different equations. Right, non-proportional. Y equals negative 5x. Can my equation have a negative constant of proportionality or a negative slope? Yeah, it can. So is this a proportional or non-proportional? Right, proportional. Y equals 3/5 x. Do I have anything extra past my variable? Nope. So it is proportional. And then the last one says 10.525x minus 2. Do I have anything extra after my variable? Right. So then it is non-proportional. Okay. So we went over the 4 different methods, and you're going to see this. Again, this is an overview. So please make sure that you also view and follow your teacher's videos, because those are going to go a lot more in depth and detail. Okay. But continue doing your best. We're in this together. Again, reach out to either myself or your teacher if you need any help. Okay. We are here for you. Okay. This is not to fail you. This is not to punish you or anything like that. This is because we need to make sure and guarantee that you understand all of this information so that you are prepared for Algebra 1. Keep up the good work, guys. Thank you.